Last thing we're going to work on is solving rational equations when we have powers of 2, quadratics, in our denominator. So let's go ahead and look at this first one here. I see an x squared, a 5x squared, and a 5x. And looking at that, my common denominator is going to be 5x squared. So for the first one, I'm missing a 5, so I'm going to multiply top and bottom by 5. Second one, I have everything I need. I have a full 5x squared. And the last one, I have 5x. I want it to be x squared, so I need to multiply by another x. Note that I don't need to square the top and bottom. I need to multiply by one more x on top and bottom. Squaring the top and bottom is never going to be a valid thing you can do when you're changing an expression. So now I have something over 5x squared, something over 5x squared, something over 5x squared. And if we remember how our rules were working out above, we can multiply both sides of the problem by 5x squared, and seemingly magically, all of our denominators will go away. We've multiplied through and we've canceled them out. So we're left with 5 times 1 is 5 equals 3 plus 1x, or x. Subtract 3 from both sides, and we get x is equal to 2. Now here's what's weird about these problems, is whenever you have squareds going on in the problem at some point, you need to do something called checking for extraneous solutions. So we need to go back to our original problem, and we need to plug that 2 back in everywhere we see an x. So let's go ahead and try that. Everywhere we see an x. So if I plugged in an x squared down here, that's going to be 1 over 2 squared, or 1/4. So I'll write that right here. I have 1/4 equals, and then 1 over, or 3 over 5x squared. So 5x squared would be 5 times 4, or 20, so 3/20ths, plus 1 over 5x, and if x is 2, so 1 over 5 times 2, 1 over 10. If I get myself a common denominator on this side, I'm going to have 3 over 20 plus 2 over 20, multiply top and bottom by 2, I would get 20ths for both of these. That's 5 over 20. And 5 over 20ths is equal to 1/4 if you reduce it, divide top and bottom by 5. And that's what we expected it to equal. So it does work. So it is not an extraneous solution. X does equal 2. There will be times where you get the answer, you plug it back in, and it will not work. It will give you a incorrect answer, and that seems to come up even more with negatives, but it can happen a lot of times with positive numbers as well. One more example we can work on is going to be number 12. When we look at our denominators, I have an x squared, a 2x squared, and an x. My largest number is a 2, and my only number is a 2. My highest power of my x's is x squared, so 2x squared, which means multiplying top and bottom of this one by 2. Notice how I put parentheses on that numerator because there was addition or subtraction going on. I didn't want to miss anything. I have everything I need on this one, and this one needs both a 2 and another x. So I'm going to multiply this top and bottom by 2x. We're getting used to our drill where every time we get like denominators all the way across, we can get rid of the denominators, and what we're really doing is multiplying both sides of the equation by 2x squared, but the shortcut in our heads might feel like we're crossing it out once we get them in common. We distribute what we have here, so we get 4x minus 4 plus x plus 5 equals, and we have to distribute this 2x to the other 2x, so 2x times 2x would be 4x squared. 2x times 4 would be 8x. And now we need to start combining things together. Whenever we have a squared term and it doesn't look like it's going to cancel out, we want to, instead of getting x on one side and numbers on the other, we want to get everything on the same side. So in my case, I'm going to say let's get everything to the right side of the equation. So to do that, let's combine our like terms first to get 5x, and our like terms negative 4 and 5 to be a positive 1. Then I'm going to subtract 5x from both sides and subtract 1 from both sides. And I'm left with 0 is equal to 4x squared plus 3x minus 1. Now to factor this is actually a pretty complicated factoring problem. We have to do the three-step factoring, if you remember way back from section 7.4 when we were doing different factoring techniques. This is one where there's nothing we can factor out all the way across, so we can't do the quick one-step factoring. We need to do this multiple step process and see if we can remember this. So we have 4 times negative 1 is negative 4. And we want two numbers that multiply to negative 4 and add to positive 3. So we have 1 and negative 4, or 2 and negative 2. These add to negative 3, so let's switch our signs so that they add to positive 3. And we're going to use that to rewrite this problem here. So 0 is equal to 4x squared, and we're going to split that middle term up into minus 1x plus 4x minus 1. And these two terms are both going to be, two chunks are going to now factor. So we have an x in common that we're going to pull out front, and leaving us with 4x minus 1. Over here we have nothing in common, so we're going to put a 1 out front and do 4x minus 1. Since the groups are the same, we take the 4x minus 1 out front and the x plus 1, the leftovers, as a group. And now we have it fully factored. 0 is equal to all of that. And since we're trying to find solutions, what we want to do is we want to say what's going to make these go to 0. It's kind of like solutions to quadratic equations that we were looking at last unit. In fact, these are solutions to quadratic equations, and it's similar in a lot of ways to when we looked at excluded values. So let's start with the second group because it's a little bit easier. The number that you could plug in for x into the x plus 1 group would be negative 1. That would make it go to 0. For this one over here, 4x minus 1, a little less obvious, so let's write it out. 4x minus 1 equals 0. Add 1 to both sides. 4x equals 1. Divide by 4. X equals 1/4. So 1/4 is going to be the other solution. So after all that work, we have two answers, 1/4 and negative 1. The part that might be a little frustrating at this point is we don't know if these answers are for sure going to work. There's a possibility that these answers are no good. We need to plug them back into the original problem to make sure. Let's start out with 1/4. 2 times 1/4, you can do that in your head or in your calculator, is going to be 1/2 minus 2 over 1/4 squared is going to be 1/16. 1/2 plus 5, I'm going to write that as 5.5 for now, over 2 times 1/16, because 1/4 squared is 1/16. So 2 times 1/16 is 2/16, or 1/8. That is equal to 2 times 1/4, which is 1/2, 0.5, plus 4, going to be 2.5, or 4.5, over x over 1/4. Now the 1/2 minus 2 that we got over here, 1/2 minus 2 is going to be negative 1.5. So let's keep these as decimals, make it a little simpler on us. And I want to be able to verify that this is a true equation, that this really works. One way to do that is get rid of these fractions by multiplying top and bottom by the same thing. If I multiply top and bottom by 12 here, top and bottom by 8 here, and top and bottom by 4 here, I'm going to be left with 1 in all of my denominators. Because then the 12 and the 1/12 would go to 1, 8 and the 1/8 would go to 1, and 4 and the 1/4 would go to 1. On top, 12 times negative 1.5 is going to be negative 18. 8 times 5.5 is going to be 44, and these are things you can do in your calculator. You don't feel like you need to do these in your head. And 4 times 4.5 is going to be 18. So I have negative 18 plus 44, and if I solve that out, I'm going to be left with 26. So this problem says 26 equals 18. And I know that that is not true. That means, unfortunately, that this solution here, this 1/4, is actually extraneous. It is not a real solution. So even though it came out when I factored it all as being supposedly a real solution, there is something wrong with it. It is not correct. Now we have to go through that whole process with -1. You can see how this can be a bit of a pain. We plug in a -1. I have 2 times -1, which is -2, minus 2, that's -4. -1 squared is 1. -1 plus 5 is 4. 2 times -1 squared, or 2 times 1 is 2. 2 times -1 is -2. -2 plus 4, 2, over just -1. So simplifying this, this is -4 plus 2 equals -2. And that is true. -2 does equal -2. So that one works. So our other solution, that x equals -1, does work. So we have one answer, and the answer is that x is equal to -1. So again, these can be range from relatively simple to insanely complicated. Take your time with them. If you're using your calculator, please promise that you're using insane amounts of parentheses. Every fraction should be fully wrapped in parentheses. Numerators and denominators should each be wrapped in parentheses if you want to just make sure you're being very safe and very correct with your order of operations, because your calculator does not always naturally do the order of operations as you expect. Good luck.